Hello friends, in our last lecture we have learned the method of bisection. What is bisection method? It is the method used to solve the roots of the nonlinear equation. So in this method we have actually taken the interval, let's say a and b, and we are halving the interval into its mean value by taking mean value. If a b is the interval, then mean value will be c is equal to a plus b by 2, and in that sense we are making half of the interval to get the closer approximation of the roots, which is the new interval which we have defined is as half as the original interval. Now we are going to learn the another method. Is see, bisection method actually may not actually it requires more number of iterations, and also it is not very efficient method. So we are going to learn false position method, which is named regula falsi. In false position method, the non-linear function which is shown in this figure, let's say fx is a non-linear function here. Fx is a non-linear function here. We assume that this function is, instead of non-linear, it is linear, and whatever roots of this linear function which crosses the x-axis, you can see here, which crosses the x-axis at any point c. So solving solution of this interval, not necessarily the solution of the non-linear equation, but it is definitely going to help us in finding the roots which is near to the actual root of the interval, which is here at x equal to alpha. So in false position, the non-linear function is assumed to be linear function gx in the interval ab. The root of the linear function is taken as the next approximation of the root of the non-linear function. So when you iterate next time, like we were doing in bisection method also, you take that root of the linear function which crosses the x-axis at c. This method is also known as linear interpolation method. Okay, why the name false position? Because the root of the linear function is not the root of the non-linear function x at x equal to alpha, and that is the name, the false position. In Latin language it is regula falsi. So that is why the name of the method is given. As we have seen in the bisection method also, that we here also we get the two intervals, which is AC and CB. There also we were getting a new interval to iterate as AC and CB, and which one to choose, that we have to decide based on the signs of the function that we are evaluating. So we will see how this method works, and here it is mentioned as in the interval halving section, the interval containing the root of the nonlinear function is written. So what this is, if we are taking half the interval, the root of the nonlinear function is written, so the roots remain bracketed in bisection method, and similar thing will also happen here. Only thing is the roots are bracketed, that's what they are saying. So we assume that a function fan, just like in bisection method, we have to assume that function fa and fb have the opposite sign. This is important. This we have seen in bisection method also. And the bisection method use the midpoint of the interval as next to iterate. Okay, there we have used c, value of c, as which was the midpoint of the interval for the next iteration. And as I told you, there is a limitation with bisection method. It converges fairly at slow speed, and that is the reason now we will discuss about this method. So better approximation is obtained when you find the point C on the x-axis by this second line L, which is shown here in dotted. This is second line L, joining the points AFA and BFA. So this is your function coordinates AFA and BFA. Okay. Now, and in either of the cases, there are two cases, 1 and 2. In either of the cases, this is going to cross the x-axis. Now, two possibilities, that if function fa and fc is less than 0. Okay. If function fa and fc is less than 0, if it has opposite signs, for example in the first figure, here you can see the fc is opposite to the x-axis, so it should have negative value, whereas fa should have positive value. So if you multiply both, you will get less than 0, and then we can squeeze the interval from the right. From the right we can squeeze the interval. So we will see in our next slide how this is going to happen. Now in second case, if fc and fb have opposite sign, you can see here fc and fb is here, both have opposite sign, then we have to squeeze the interval from the left. So meaning of this is fa and fc is, in another language, fa and fc is less than 0, or fb and fc is greater than 0. Both are same, both the meaning of both is same. So if this is a case, a 0 lies in interval AC, and that is the reason why they have told that we can actually squeeze from the right. So 0 lies in interval AC. We have to squeeze the interval from the right this way, and your interval becomes within your root. Basically, root lies within A and C. Whereas in the other case, you have to squeeze the interval from the left. That means your root here, you can see here the root lies in the interval C and B. So that is what the idea, C and B, interval here C and B. So if this condition, first condition arises, then we have to take B is equal to C to squeeze out the interval from the right, and in the second case, to squeeze out the interval from the left, we have to take A equal to C for our next iteration. And similar same thing, above thing is true for the bisection method as well. We have applied this condition. If fa and fc is less than 0, you take b is equal to c and keep a is equal to a as it is for the next iteration. And if second condition arises, fa and fc is greater than 0, then take a is equal to c and b is equal to b. But the geometrical interpretation of this is given in this figure, and you have to understand it clearly, both applicable both to bisection method as well as false position method. Okay, so this is simple second line joining A and B in both of the cases. and wherever it crosses your x-axis, you can write now two different slopes in different version, which one of the slope equation will include the unknown quantity, which is this fa and fb, and second time slope will include these coordinates c0 and b f0. So let us see how it goes. So two different slope equation are shown here. So to find the value of c, we want to find the value of c, where your linear function, which we have assumed, linear function, this L, the dotted line, actually dotted line crosses the x-axis. That is, at here we want to find point C, and which is closer to your root. So this is definitely going to be faster than the bisection method, because they are continuing. If your A and B is you are not achieving it closer too early, so the speed is very less, whereas here you will quickly achieve the closer interval, the bracketed values, and the value of C within that bracket as early as possible. So by writing two different slope equation, you can see here m is equal to fb minus fa divided by standard slope equation, because we have the coordinates of and you can use the standard slope equation of m is equal to fb minus fa divided by b minus a. And second equation, which uses 2 points, first equation, as I told you, uses these two ordinates. Second equation uses c0 and bfb ordinates. So again, by applying standard slope equation, 0 minus fb divided by c minus b. Now slope for both the equation, slope is 1, slope is same, so we have to equate that slope. So let us equate the slope, and we are getting fb minus fa. As I told you, here the point c is 0 and bfb is used in the second equation. Now equating this slope, we are getting this equation, and from this our objective was to find value of c. So we have obtained c value. So in that process, you have to evaluate these quantities fb, fa, b minus a, b. You substitute these values, and I told you, after evaluating the function with value of c, fc, you have to evaluate fc using this c value. Again, if you recall the bisection method, we have again the three possibilities, as I have already discussed in the figure in the geometrical interpretation of this method, that there are three possibilities, that fa, and it is the same but written in a sentence, that fa fc have opposite sign. If then a 0 lies in AC, then take B is equal to C for the next iteration, and take A is equal to A. Second possibility, if FC and FB have opposite sign, a 0 lies in the interval CB, then take A is equal to C and B is equal to B for the next iteration, and evaluate the function again. So if FC is equal to 0, then 0 is a C. So this is one example which I am showing here. You have to redo this example. X sin x minus 1 is equal to 0. This is our function where we want to find the roots. So assume that this is located in the interval 0b. Now we have to check that fa and fb has to be in opposite sign. That's the condition, and that condition was prevailing in the bisection method also. So convergence equation, convergence of the false position method equation is used to construct the sequence of the intervals an and bn, because we have to introduce n subscript here to get the sequence of the intervals, and we have to construct the sequence at each of which brackets the 0. We want to see every time whether these interval brackets any 0 value. So next is we have introduced the same equation with subscript n, because now we have to introduce the iteration here. Everywhere subscript n is introduced. So starting with 0, because we have our interval initial value 0 2, that was the interval. So let us name it a0 is equal to 0 and b0 is equal to 2. So we have to evaluate and check that opposite sign condition first, whether our interval, by evaluating the function of that interval values, whether we are getting opposite sign. So we have taken f0 evaluated, turns out to be this, f2 turns out to be this. So multiply, you will get less than 0. That means both are in opposite sign. fa and fb, fa0 and fb0 has to be in opposite sign because you are getting less than 0. So the root, we can say okay, the root lies in the interval 0 2. Now using this above formula, we can evaluate c0. c0 is for the first iteration. Substitute all the values, you get this answer. And then evaluate function using fc0. fc0, and for that answer is this. Now how to go next? Okay, we have to check this condition. Every time you have to check this condition. Please understand, this is important. Every time you have to check this condition. fa, once you evaluate fc0, just compare it with fa0, multiply it, just check this condition. If fa and fc greater than 0, you have to take next iterative value for a1 is equal to c0. So c0 आपका a1 will become a1, and b is equal to as it is, that is b is equal to b0. But if it is the other way around, just take b as your c0 and a1 remains a1. A0 remains a0 for the next iteration. A0 remains a0 if the opposite sign is there. But if this is the case, it is a1 is equal to c0, whereas there is b1 becomes c0 and a0 remains a0, whereas here b0 remains b0. So the function changes its sign in the interval c0 and b0. So you can mention here c0 b0 interval, because we will have to check whether it is giving you the opposite sign. So we have to squeeze the left, whatever written here, it is the same thing here. a1 is equal to c0 and b1 is equal to b0. For the next value, we have to repeat the value with the same iteration. So use the same formula to produce the next iteration. So evaluate c1 and you get this value. So we have evaluated, we have taken c0 and b0 for our next iterative value. Once you check that, once you evaluate that function, this condition will prevail. This you have to ensure. I have not written the actual values of the function, but it turns out to be a1 is equal to 0 and b1 is equal to b0 for the next iteration. you can take. So finally you are getting FC1, this value, and we again have to check whether the fx changes the sign in this interval. For example, earlier we have checked whether fx was changing its sign in this interval C0 and B0, and we came to the conclusion that okay, it uh, it is FA and FB. Depending on the condition which I shown earlier, it turns out to this. So this you need to verify. So next decision will be based on that whether we want to squeeze from the right or the left. So second case, we have to squeeze from the right and set A2 is equal to A1 and B2 is equal to C1. Summary of the table calculation is shown here. So first shows the iteration number, second shows a left hand point, midpoint and the right point. So AK, CK and BK, and the value of the function FCK. So just regulate and you are getting this answer. You have to measure the sign in the radian